So what we've been doing so far is we've been taking solids and adding gases to them, or solids and reacting them with other solids, or solids and blah blah. We've been dealing a lot with solids. So now what we're going to do is we're going to move into the world of solution chemistry. So the chemists who deal with the solids are called dry chemists. The chemists who deal with the solutions are called wet chemists. And so there are these two different fields of chemistry. It's two subdivisions of chemistry. Wet chemists are the ones who you see like in the mad scientist movies where they have these blue colored liquids and they add it to the orange colored liquids and foam starts happening and they change colors. That's what a wet chemist does. So these are using solutions. And many reactions in chemistry use solutions. So what are a solution? A solution consists of one or more solutes dissolved in a solvent. This will become a homogeneous mixture. Remember, we've learned what homogeneous means. It means that there is no phase separation. You can't determine one part of the solution to a different part. They all look the same. So this is like your salt water solution. You don't have chunks of salt floating around. It's all just dissolved in this water. So that would be considered a solution. Now there were two words in here that I haven't talked about yet. A solute is the thing being dissolved. A solvent is the thing that's doing the dissolving. So in our case, our idea of this sodium chloride solution, the salt water, the sodium chloride would be the solute because it is being dissolved. The water would be considered the solvent because it is the thing doing the dissolving. So these are two different definitions that you should know. They become important when dealing with this idea of solutions. What's a concentration? Well, this goes back to your childhood when you were making Kool-Aid. Okay, I always go back to food, you know this. Kool-Aid, if you add more sugar to the solution, to that liquid, it tastes better to a point. You can get way past the point of tasting good with sugar, but to a point it tastes very good the more sugar you add. That's because you're making the sugar molecules more and more concentrated in the solution. So there are more sugar molecules per volume of solution when you add more sugar in. Now, if you were my mom, you would wait till the very bottom and you're almost out of Kool-Aid and then just add more water. Well, that's a very dilute solution. The sugar molecules are far apart from each other within the solution and it doesn't taste as good. So the concentration of a solution is given by the quantity of the solute, the amount of thing being dissolved, in a given quantity of solution, not solvent. So the solution is the actual amount of the total solution. So we'll talk about this a little bit more tomorrow. It's kind of a tricky little fine point in chemistry. So concentration and molarity are kind of interchangeable when talking to general chemists. Molarity is our new unit that's going to be used to express concentration. So you'll hear me go back and forth. Concentration or molarity, in my mind, they're interchangeable. So what is this new unit? Well, molarity is written as a capital M, italicized. So capital M. And it has a very specific definition. Molarity is equal to the moles of solute. So your solute has to be in moles divided by liter of solution. So this does not say liters of solvent, this is liters of solution. So we'll talk about what that means a little bit more tomorrow. So we'll have to have moles per liter of solution. If you have grams per milliliter of solution, that is a density unit. This is a concentration or a molarity unit. So this is a very specific definition in chemistry. Moles of solute per liters of solution. We can write that as capital M is equal to moles of solute per liter of solution. That's just what the definition of molarity is. Now we have a new unit, and it looks like we have this ratio, which means we have a new dimensional analysis quantity that we can use when moving from one unit to another.